When you're dealing with selections that contain groups, there's two main principles that you need to use. You need to start by considering the number of ways that you can order the groups, and then consider the number of ways that you can order the items that are within each group. And that word each is important because there might be more than one group in your question. Once you've got those two numbers, you just multiply them together to find the total number of possibilities. And remember that a group can consist of just one item. So looking at an example, here we've got 4 boys and 4 girls who are forming a queue at a bus stop. There's a boy-girl couple who want to stand beside each other, and the 3 other girls also stand together. The other boys don't mind where they stand. How many possible queues can be formed? Now we've got 8 positions in the queue, but we need to consider how many groups we've got. We've got the 3 boys, they're each in a group of their own. 1 group, 2 groups, 3 groups, that's the 3 boys. Then we've got the couple, that's another group. And then we've got the other 3 girls, that's a 5th group. So there's 5 groups altogether. So if we just organise the groups in as many different orders as possible, we're going to have 5 factorial ways that we can put those groups in different orders. But within those groups, there's 2 ways that we can order the couple, because we could have the boy and then the girl, or the girl and then the boy. So that's 2 factorial ways, or we could just write 2. We know that 2 factorial just is 2. And if we're ordering the girls, then there's 3 of them that could be at the front of their little bunch, and 2 who could be second, and 1 that will have to be last. So there's 3 factorial ways that we can order 3 people. So now we just need to multiply these together. Now again, some people love this box method to actually write down what they're doing in each box. This is a great idea when you're learning, but once you get good at this, you'll find that you can just think through what to do without writing the boxes, and then just multiply your numbers together. So then use your calculator with your factorial button. 5 factorial multiplied by 2 times 3 factorial, and we get 1440. Our basic unit on probability investigated complementary events in quite a bit of detail, and we found that using complements was a really great idea when we're interested in something that has a whole lot of possibilities, because it's often quicker and easier to consider the total probability and then subtract the probability of what you don't want to get the probability of what you do. And the same sort of concept applies when we're counting selections. If we want to count selections and the ones we're interested in have heaps and heaps of possibilities, it could be quicker to just count the total number of selections and then subtract the number of selections that you don't want, so that you're left with the ones that you do. So let's have a look at an example here. How many 7-letter words, now we know that a word is just a combination of letters, how many words can be formed from A, B, C, D, E, F and G if the vowels must be separated by at least 1 consonant? Now, quick inspection tells me that we've only got 2 vowels here and we've got 5 consonants. So if the vowels have to be separated by at least 1 consonant, and remember in our probability unit that word, that phrase at least was often a good trigger to tell us that complements might be helpful. Well, if they can be separated by at least 1 consonant, they could be separated by 1, 2, 3, 4, or 5 consonants. So to work out all of those 5 different scenarios and add them all together is quite a bit of work. What's the opposite of being separated by at least 1 consonant? Not being separated by any consonants at all. So if we can find the number of words that have no restriction whatsoever, and then subtract the number of words that have the A and the E together, not separated by any consonants at all, then we should be left with the number of words that have A and E separated by at least 1 consonant. So the number of words with no restriction whatsoever, well, there's 7 possibilities for the first letter, 6 for the next, 5 for the next, so on and so on. So we're going to start with 7 factorial. Let's work things out as we go. So that gives us 5,040 possible words that we could make. Now, the number that have A and E together, consider what happens when you have to group some things. There's 7 letters, but if the A and the E are together in one group, there's basically 6 groups, because the A and the E form one group, and then the 5 consonants are in their own individual groups. So the number of ways that we can order 6 groups is 6 factorial, but we have to consider that that little group of A and E can be ordered in 2 different ways, because there's 2 different items there. So we need to do 6 factorial times 2, which gives us 1440. So now if we subtract 5,000 and do 5,040 minus 1440, then we should get 3,600. And that would be the number of words that are separated by at least one consonant.